Okay, so here's a question now where you're going to just strictly use the calculator. I'm not going to give you the graph. Here's the equation. Figure it out. Okay, so couple things before we even start putting things into the calculator. Look at this. We got the equation down here. We can figure out, look at that, direction of opening. Obviously, it's going to be negative, unhappy parabola. It's going to be opening down. Vertex, can't figure it out yet, but maximum value, can't do that either, right? Equation of the axis of symmetry, we don't know. But in the sense that it's opening down, we know that we're getting to a max. So there's not going to be a min, okay? The max value is going to be something. X and Y intercepts. Well, wait a second. What does X-intercept mean? X-intercept happens when Y equals to 0. What's Y-intercept mean? That happens when X equals to 0. Let me show you something. If X equals to 0, right? Look what happens. That means this value is gone. That's 0. 0 squared is 0. Look at this value. 2 times 0, that value is gone. That gives you 0. Look what's left. Plus 8. That, in fact, is, guess what? Your Y-intercept. There you go. Y-intercept, I've given you at least something there. So your Y-intercept happens at Y equals to 8. Beautiful. Okay, so let's figure out the rest. How do you figure out the X-intercepts? Well, I said earlier, X-intercepts happen when Y equals to 0. Uh-oh, so what does that mean? That means this guy would be 0, so you'd have 0 equals to negative X squared plus 2X plus 8. How do I figure out the X values? That's, again, where we're going to bring in the calculator. So let's bring up the calculator. Let's see what we can do with it. Okay, there it is. Boom. Oh. So there's my calculator. I put the equation in. I'm going to hit graph. Bada boom. There it is, and it gave me my beautiful drawing right there. And you can see that it, in fact, is opening down. And we've got a vertex that looks like it's pretty close to 1, 9. But let's figure out what that vertex is. How do I figure out the vertex? Well, I put it here in red for you here. That's the maximum value. Remember? Okay, so bring up the calculator. Let's figure out the max or min. Well, we know it's going to be a max because it's opening down. So second, calc, opening down, we're trying to find the maximum. There's the 4. And again, it comes with left bound, right bound. So let's put that left bound, right bound in there. So we go to the left side of the vertex, which is over here, enter, and we go to the right side of the vertex, which is over here, enter, guess, yes, okay, and we get 0.999999. Well, wait a second. That's a problem with this calculator. It has an issue sometimes with exact numbers. But if you think about it, 0.999999999 is actually very close to 1. So this vertex is 1, 9. So let's put it in there. 1, 9, which look at all the wonderful things this now answers for us. The max value, oh, simple. The max value is 9. The equation of the axis of symmetry, x equals to 1. Axis x, x equals 1. So now that we've got the vertex, see how valuable the vertex is? It tells you so much more information. The only problem we have right now is we still don't have the x-intercept. So I'll get to that in a second. Let's do the domain and range. Domain, yeah, pretty standard. X is an element of R, but the range here is Y. Because it's opening down, it has a maximum value, which means everything else has to be less than or equal to the maximum, which is 9. Now, let's find the X-intercepts. But like I said before, I gave you a hint. You're going to use this function on the calculator, which is quite unique. It's called the 0. Why do we call it the 0? Well, remember, to find the x-intercept, y has to equal to 0. So find where it is 0. That's how you do it. Okay, so here comes our calculator. Let's go to second, let's go to calc, and sure enough, number 2 is 0. Awesome. So let's go right to 2, and look what it says. Again, left bound, right bound. Well, what are we talking about? Remember, left side, right side. So if you think about it, let's find this guy first. Let's find that one. We have to be on the left side of that dot. Okay, here we go. Mouse, 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 mouse. And let's see if we can go over to the left side. And there it is. It's on the left side. And if you don't believe me, you hit enter. And look, it even puts a dotted line on the newer calculators. It'll put a little dotted line saying that's your left bound. Now it says find the right bound. Well, guess what? We have to go to the right side, which means we move a little up. We hit enter and look, there's the right side of that. And just say guess, go yup, there it is. And look at that. It tells you at -2, 0 is one of the X-intercepts. Oh, cool. Okay, so we're going to put an X-intercept here at -2, 0. Beautiful. Well, let's find the other one. Exactly the same way. Exactly the same way. So we're going to try to find this guy. Left bound means you're going to be somewhere up here. Right bound means you're going to be somewhere down there. So here we go. Let's go. Second, calc, find the 0, which is 2. Left bound. Okay, here we go. Up and over and down. There's the left side right about there somewhere, and I'll move it down so you can see it. Okay, anchor it. There's the left side of that green dot, and now find the right side of the green dot, which is right here. Okay, enter, and look how it bounds it left and right. Guess, of course, and look how it gives you a value of 4, 0. So there's your other intercept. And as a matter of fact, if I erase these dots, you can see that it's blinking right on the X-intercept. So 4, 0 is the next one. Okay, so our other X-intercept is going to be 4, 0. Perfect. And I've just answered everything on this question, but I haven't sketched it yet. Now check this out. When I sketch this thing, it becomes really, 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 really cool, because look what I've got. I've got, of course, a vertex at 1, 9. I have a y-intercept at 8. I have intercepts here of the x-intercepts here and here. Look how much more accurate our graph is getting, and that's what's really, really important. Before, I gave you a vertex, opening up, opening down, wide or narrow. That's done. But now look how accurate this guy becomes. It's really, really cool. Here, vertex, 1, boom, 1, 2, 3, 4, 5, 6, 7, 8, 9, right up here, boom. We're told a couple of other things here. We're told that we have an intercept at 8. So look, there's an intercept at 8. But I want to show you something. If that's our axis of symmetry right here, and that's 1 over, that means 1 over here, guess what? That and that are going to intersect right there. Look, that's 1 from the axis of symmetry. That means that's 1 from the axis of symmetry as well. Isn't that neat? So that one intercept gives us 2 points. And we have an x-intercept at -2, 1, 2, right here, and a y-intercept at 4. 1, 2, 3, 4. So this goes down through here. This goes down, in fact, through here. So look at all of the information here. I can comfortably say that I've got an incredibly accurate diagram. An incredibly accurate diagram with all of that information. I can rest assured that that's what my parabola looks like in real life. So some really cool stuff on the calculator on this one, and some really cool actual dots, so we don't have to be predicting anymore and sketching. We're actually graphing quite accurately.